Hi again everyone, here's the fun and games, here we go. This is out of the textbook written by our wonderful Western Australian textbook writer AJ Sadler. I've taught in 3 states, I love what he does, textbooks are great. We were looking at, this is a 12 specialist course here on vectors, and it's exercise 8F, and he's got this example 15 before it. So it's find the perpendicular distance from the point A, position vector 34i plus 12j, so there's its position for A, to the line L, and that line L has this vector equation. The only thing that matters at this stage for this question is the direction of that line. So it goes through, if I had a 10i and a 14j, and it goes through in what direction? It goes in the direction of 5i plus 2j. So the first bit is its position, there's its direction. So we only need that direction in a moment, because we're going to use that and the perpendicular for this, this vector here. So we need to do the direction of this line multiplied by vector AP. Because from the dot product, if you multiply one vector by another and they're perpendicular, you get 0. So I'm actually going to get rid of that because I need space in a moment. We'll even get rid of that. So there's your direction. We've got that over there. Okay, here we go. So we want to know how do we get AP. So let's go back to this again. I'm going to have 5i, I'm going to put it right over here, times by AP. Excuse me if my brain goes a bit slow on this, we want that. So I already know the first bit, I've got to get AP. So how do I go from A to P? If I have a different colour pen, I've got to go back to here. So AP vector, we're going to go AO, and then we're going to go all the way back out here to P. So that's OP. Now AO is easy because it's the reverse of position A. So O to A would be that, so A to O would be the minus of that. So I can just write the minus of 34i plus 12j. Plus now I've got to get this OP. Question is, where is this P? Now we don't know where it is, so if I go back to the original equation of this line, we're at any position called lambda, but we don't want any position, we want a particular position. In this case, I'm going to call lambda 1. So now, OP for this point here, so I could write on here that this point is actually 10i plus 14j plus lambda 1 of 5i plus 2j. So a particular point rather than any point. And we're going to try to find out where that point is. So here we go. So now if I go OP, because I'm going from O, which is 0i plus 0j, is just that point there. So I go 10i plus 14j plus lambda 1 of 5i plus 2j. Remember to underscore everything in Western Australia for the Year 12 spec exam. You must have the underscores or you will lose a mark. Let's have a look at what we got here now. I need all the I's and I need the J's. So I've got to try to shortcut this process. Minus 34i plus 10i. So I've got minus 24. Now I've got 5 lambda 1i. So I've got 5 lambda 1. And they're all the i's. So there's my I components. Let's go to the j's. I've got minus 12 plus 14. So what have I got now? I've got 2. So minus 12j plus 14j is 2j. I'm going to put the j's out there. And what have I got for the last bit? 2 lambda 1j. So that's 2 lambda 1. So there's my vector AP. Now I've got to multiply this direction, this vector, multiplied by all of this. So I could write it all in, no, let's do it. Little problem in my presentation there. It's the whole vector. Old school, we always did a square bracket. So the first one in here is actually called parentheses, and these are officially called brackets. How do I do a vector multiplication? Of course, that's got to equal 0. because they are perpendicular by their nature. So how do I do this? I multiply the I component by the I component. I can multiply the I by j, but it does nothing because any I multiplied by j is perpendicular and the dot product of I and j is 0. So if I've got an ij, that equals 0. If I've got a ji, that also equals 0, so they just drop out. The reason they drop out is that I dot j, back to the basics, is the magnitude of I by the magnitude of j by the cos of the angle in between. So the magnitude of that's 1, magnitude of that's 1, and that's the cos of 90, and the cos of 90 is 0, so that's 0. So whenever you multiply the i's, they count. So to multiply two vectors, dot product, so what have we got now? We've got the 5 times all of that, so we've got 5 times minus 24 plus 5 lambda 1 plus the 2 times 2 plus 2 lambda, excuse me, has to equal 0. So what have we got now? If that, I'm out of time to go through the calculations there, but I've written it over here and done it earlier. You can go through it yourself. Lambda 1 is 4. Now what does lambda 1 have to do with things? I've got this vector called AP. I've written it up there in case I rub it off. I've got this vector AP, and I now know that lambda 1 is 4. So I can go back and I can go substitute, lambda 1 equals 4, and I've got that AP is minus 24 plus 5 times 4 I plus 2 times 4 j. So easy to make silly mistakes here, I'm trying hard. Minus 20, so that's minus 4i, and then we've got the 2 plus the 8, which is plus 10j. So what does that mean? It means that this vector here is minus 4i plus 10j. And if I had a reasonable diagram, you can see I've gone across 4 and I've gone up 10. But we want to know the distance, so that's the magnitude of AP, which is the square root of 4 squared plus 10 squared, which of course is 16 and 100, so that's the square root of 116. And of course you could break that up into root 4 and root 29. A bit easier when I know that in my head. And we've got 2 root 29. So vector AP, we now know what it is, and we know how long it is. So we've now got the distance from A to that line. Wow, mate, thanks very much. Bye.